On July 1st, 2025, a routine sky survey conducted from the arid Atacama Desert in Chile picked up a faint anomaly, a speck of light that initially appeared unremarkable. But further analysis revealed something extraordinary. This object wasn't just another asteroid or comet drifting within our solar system. Its trajectory screamed interstellar origins. It was a visitor from beyond, only the third such object ever confirmed by humanity, following in the enigmatic footsteps of Oumuamua. Astronomers, naturally excited, christened it 3I Atlas, the 3I designating its status as the third interstellar object, and Atlas referencing the survey system that discovered it. The initial excitement, however, soon morphed into profound bewilderment. As 3I Atlas drew closer, defying the expected behavior of conventional comets and asteroids, it unveiled a series of bizarre characteristics that challenged existing astrophysical models. This wasn't just a cool discovery, it was the opening chapter of a deep cosmic mystery. The first clue that 3I Atlas was anything but ordinary came from its chemical composition. Astronomers using the Very Large Telescope, VLT in Chile, analyzed the light emanating from the object's coma, the fuzzy envelope of gas and dust that surrounds a comet's nucleus as it heats up from the sun. Typically, cometary comas are rich in water vapor, dust, and traces of common metals. But the spectroscopic data from 3I Atlas told a different story. A very different story. Instead of the expected cocktail of volatile compounds, the analysis revealed an astonishingly high concentration of pure nickel. I mean, pure nickel. This immediately raised eyebrows. Nickel isn't unheard of in space, of course. It's a relatively abundant element forged in the fiery furnaces of dying stars. The catch? In the cosmic realm, nickel and iron are virtually inseparable siblings. They're born together, intertwined in the same stellar processes, and almost always found in close proximity. Think of meteorites that crash to Earth. They're packed with both nickel and iron, often in roughly equal proportions. But when scientists scrutinized the data from 3I Atlas, the iron was conspicuously absent, almost completely missing. The nickel was there, shining brightly in the spectra, but the expected iron signature was nowhere to be found. It was like finding the peanut butter without the jelly, the gin without the tonic. Simply unheard of. The object, as it sped through space, was shedding around 5 kilograms of nearly pure nickel every single second. Just try to wrap your head around that. This is where the story takes a sharp, unexpected turn. Suddenly, this interstellar visitor wasn't just a fascinating curiosity. It was a perplexing anomaly that seemed to defy the known laws of astrophysics. Because here's the thing nobody's telling you. Separating nickel from iron on a large scale isn't a natural process. On Earth, it's an industrial process. It requires immense energy, sophisticated technology, and complex refining techniques. You don't just stumble upon veins of pure nickel ore lying around, especially not in the vacuum of space. The scientific implications were staggering. How could nature possibly produce such a unique and improbable object? The abundance of pure nickel, coupled with the scarcity of iron, suggested something far more unusual was at play than simple cometary activity. Could some unknown astrophysical process be responsible for this strange elemental segregation? Could extreme conditions within another star system have created this nickel-rich anomaly? The questions multiplied. Was 3I Atlas a fragment of a shattered planetesimal, torn apart by tidal forces or a catastrophic collision, somehow enriched in nickel through an unknown mechanism? Could it be a relic from a long-extinct type of star, one that produced heavy elements in radically different proportions than we observe in our own galaxy? The possibilities, while intriguing, seemed increasingly far-fetched. Each attempted explanation felt like a desperate grasp at straws. The initial bewilderment quickly gave way to a sense of profound unease. The nickel anomaly wasn't just a minor detail. It was a glaring red flag, a cosmic impossibility staring astronomers right in the face. It whispered of forces and processes beyond our current understanding, hinting at a universe far stranger and more complex than we had ever imagined. 3I Atlas had arrived not as a simple messenger from another star, but as a cosmic riddle wrapped in an elemental enigma, challenging the very foundations of our astrophysical knowledge. And so, the search for answers intensified. Astronomers around the globe, armed with the most powerful telescopes on Earth and in space, began to scrutinize 3I Atlas with renewed urgency, determined to unravel its secrets. But as they peeled back the layers of this cosmic onion, they would uncover even more unexpected surprises, further deepening the mystery and leading them down a path toward a truly shocking possibility that 3I Atlas wasn't just a natural object at all. As the dust settled from the initial shock of 3I Atlas's discovery, a figure emerged from the hallowed halls of Harvard University, a scientist known for their sharp intellect and willingness to challenge conventional wisdom. Dr. Eris Thorne, an astrophysicist specializing in interstellar objects, quickly became the leading voice suggesting something far more extraordinary than a rogue comet. His intervention wasn't immediate. He, like the rest of the scientific community, initially approached 3I Atlas with cautious optimism. But as the data poured in, Thorne's initial optimism morphed into a growing conviction that something deeply anomalous was at play. Thorne's argument, meticulously constructed and presented in a series of preprints and later a highly publicized paper in Nature Astronomy, rested on two primary pillars: the object's peculiar trajectory and its baffling composition. Let's delve into the trajectory first. As we touched on, 3I Atlas wasn't just passing through our solar system, it was seemingly visiting. Its calculated path involved a series of close encounters with multiple planets, Venus, Mars, and Jupiter, within a relatively short time frame. Thorne argued that the probability of a randomly occurring interstellar object threading such a needle was astronomically low. He used advanced statistical modeling to demonstrate that such a trajectory could not be easily explained by gravitational interactions alone. The object seemed almost guided. It was as if it was executing a carefully planned itinerary, optimizing its proximity to these celestial bodies for observation. But the trajectory, while suspicious, wasn't the only thing raising eyebrows. The composition, specifically the abundance of near-pure nickel, was arguably even more perplexing. Thorne highlighted the industrial processes required on Earth to separate nickel from other elements, especially iron, the extreme energy expenditure, and sophisticated technology required to refine nickel to such purity suggested an artificial origin. Nature, he stated in a widely quoted interview, doesn't typically leave behind piles of refined metals in the vacuum of space. It crafts mountains of ore, blends elements in the hearts of dying stars, but it rarely concentrates a single element to this degree without deliberate intervention. He drew a parallel to the discovery of manufactured plastics in remote oceanic regions, evidence of human activity far beyond our immediate environment. Was 3I Atlas, he proposed, a similar artifact, a relic of a civilization beyond our comprehension? Thorne's hypothesis ignited a firestorm of debate within the scientific community. Some researchers immediately dismissed his claims as sensationalist and lacking sufficient evidence. They argued that while the nickel anomaly was indeed unusual, it could potentially be explained by undiscovered astrophysical processes or rare but natural phenomena. The exotic astrophysics argument became a popular counterpoint. Perhaps, they suggested, some hitherto unknown type of star could create the conditions needed for such unique composition. Or perhaps there was some kind of yet undocumented process of accretion or differentiation, working to separate elements in ways we just didn't understand. The initial reaction was, predictably, skepticism. The scientific method demands rigorous proof, and extraordinary claims require extraordinary evidence. However, Thorne's work was far from dismissed outright. His meticulous analysis and compelling arguments forced the community to confront the possibility, however remote, of an artificial origin. What followed was a flurry of activity as research teams around the world mobilized to gather more data and test Thorne's claims. A key element in this investigation became the James Webb Space Telescope, JWST. With its unparalleled infrared capabilities, JWST offered the potential to analyze 3I Atlas's composition and behavior with unprecedented detail. Multiple proposals were submitted to the JWST Observing Committee, all vying for precious telescope time to study the object. In the end, a multinational team led by Dr. Evelyn Reed, a renowned planetary scientist, was granted a significant allocation of time. Dr. Reed and her team proposed to use JWST to search for any potential signs of artificiality, regular patterns in the object's surface, unusual thermal emissions, or even faint radio signals. The JWST observations were, to put it mildly, a mixed bag. While they confirmed the extremely high concentration of nickel, they found no definitive evidence of artificiality. The surface appeared rough and irregular, consistent with a natural object. The thermal emissions were complex but could be explained by the sublimation of volatile compounds. And despite extensive searches, no radio signals were detected. However, the JWST data did reveal another surprise. The object's reflectivity, its albedo, was incredibly high. It was reflecting far more light than a typical comet or asteroid, which further deepened the mystery, even if it didn't definitively point towards artificiality. This was especially strange given the high nickel content, which one might expect to darken the object. Dr. Reed and her team publicly acknowledged the lack of definitive proof, but emphasized the need for continued investigation. "We haven't found a smoking gun," she stated at a press conference, "but we haven't ruled anything out either. The data we have collected is simply too unusual to ignore." The scientific community remained divided, but the debate was far from over. Thorne's hypothesis, though controversial, had forced everyone to reconsider the possibilities. The search for answers continued, fueled by the tantalizing prospect of discovering evidence of extraterrestrial intelligence. And the world waited, with bated breath, for the next chapter in this cosmic detective story to unfold. So, we've established 3I Atlas is weird. Really weird. But it doesn't exist in a vacuum, pun intended. To truly understand the implications, we need to rewind a bit back to 2017 and another interstellar oddity that shook the scientific community. Oumuamua. Oumuamua, meaning scout or messenger from afar arriving first in Hawaiian, was the first confirmed interstellar object detected passing through our solar system. And right from the start, it was unconventional. Its elongated, cigar-like shape was unlike anything we'd ever seen in our own asteroid belt. Most asteroids and comets are roughly spherical or irregularly shaped, but Oumuamua was estimated to be up to 10 times as long as it was wide. Imagine a cosmic needle hurtling through space. That's the image that stuck. But the shape was just the beginning. As astronomers tracked its trajectory, they discovered something even more perplexing. Oumuamua was accelerating as it moved away from the sun faster than could be explained by gravity alone. Now, comets often exhibit non-gravitational acceleration due to the outgassing of volatile materials as they're heated by the sun. This creates a visible tail, like a tiny rocket engine pushing the comet along. Here's the kicker. Oumuamua didn't have a tail. No coma, no outgassing detected. Nothing. So what was causing it to accelerate? This mystery sparked a firestorm of debate, and it's where things get really interesting. Enter Avi Loeb, the same Harvard scientist who's now raising alarms about Die Atlas. Back in 2017, Loeb proposed a radical hypothesis. that Oumuamua wasn't a natural object at all, but rather an artificial one, a solar sail, propelled by the pressure of sunlight. A solar sail is essentially a giant thin sheet of material designed to catch photons from the sun and use their momentum to generate thrust. The idea was, and remains, highly controversial. Most scientists favored natural explanations, like a fragment of a dwarf planet or a comet made of exotic ices that wouldn't produce a visible tail. But none of those explanations perfectly fit the observed data, and Oumuamua eventually faded from view, leaving the puzzle unsolved. Now fast forward to today and the arrival of 3I Atlas. Suddenly, Oumuamua doesn't seem like such a singular anomaly anymore. We have another interstellar object with properties that defy easy explanation. One could argue that one weird object is just a cosmic fluke, a statistical anomaly. But two? Two begins to suggest a pattern, doesn't it? It raises the tantalizing possibility that the interstellar space surrounding our solar system is populated with far more strange and unusual objects than we previously thought. So are Oumuamua and 3I Atlas connected? Are they from the same origin? Are they part of a larger phenomenon we don't yet understand? These are the questions that are now swirling around the scientific community. Let's be clear. The distances involved here are almost incomprehensible. We're talking about objects traveling light years across the galaxy, traversing the vast emptiness between stars. The sheer scale of space makes these coincidences, if they are coincidences, even more remarkable. And that's where the debate really heats up. If these objects are natural, their existence suggests that our current models of planetary formation and the composition of other star systems may be incomplete. We might be vastly underestimating the diversity and strangeness of objects drifting through interstellar space. It would force us to rewrite our understanding of astrophysics. But if they're not natural, well, that's when things get really mind-blowing. It would imply that someone or something is actively sending probes or objects into our galactic neighborhood. And that raises a whole host of existential questions. Who are they? What are their intentions? And what does their existence mean for humanity's place in the cosmos? The implications are staggering, forcing us to consider the possibility of extraterrestrial intelligence in a very real, tangible way. Are we looking at discarded technology, intentionally sent probes, or something else entirely? Let's delve deeper into these possibilities. One theory, as we discussed earlier with Oumuamua, is that we're looking at artificial probes. Perhaps these are remnants of long-dead civilizations, technological artifacts adrift in space. Maybe they're actively functioning probes, sent to explore and study other star systems. The pure nickel composition of 3I Atlas could be a component of advanced technology we simply don't understand. But it doesn't stop there. Some speculate that these objects could be examples of von Neumann probes, self-replicating machines designed to spread throughout the galaxy, utilizing raw materials from asteroids and other celestial bodies to create copies of themselves. This would explain the unusual composition, perhaps as the raw materials being used for replication. Then there's the more far-out, but still scientifically plausible, theories. What if these objects are biological in nature? Perhaps they're designed to spread life between star systems, acting as seeds of life, terraforming barren planets and initiating the process of biological evolution. 3I Atlas's high carbon dioxide content could be a component of a terraforming process. Of course, we can't ignore the possibility that 3I Atlas, despite its anomalies, is ultimately a product of natural, albeit exotic, astrophysical processes. Perhaps it's a fragment of a star destroyed in a supernova or a remnant of a neutron star collision. These cataclysmic events could potentially create the unusual chemical compositions and trajectories we're observing. But even if these extreme events can create such an object, the odds of it then being sent on a trajectory that takes it directly through our solar system, passing close to multiple planets, seem incredibly slim. which leads us to perhaps the most unsettling possibility of all, that 3I Atlas, and perhaps Oumuamua before it, is designed to be noticed. What if their strange properties and improbable trajectories are a deliberate attempt to attract attention, to signal the presence of an advanced civilization to any intelligent life that might be watching? It wouldn't be a probe to survey us, but a test to see if we're smart enough to notice, a cosmic calling card left by an intelligence far beyond our own. Ultimately, the mystery of 3I Atlas and its potential connection to Oumuamua highlights the profound ignorance we still have about the universe around us. We are, in essence, children peering out into the cosmos, trying to decipher the language of the stars. Whether these objects are natural or artificial, their existence challenges our assumptions and forces us to confront the possibility that we are not alone. The search for extraterrestrial intelligence is no longer confined to radio signals and distant galaxies. It may be happening right here in our own solar system, with clues scattered among the stars.